Afternoon, everyone. My name's Leon, and our app is called Shelfy. So the initial concept is a bookshelf scanner. So it analyzes a bookshelf and returns visual feedback based on the user's collection. The idea stemmed from, I guess, all of us thought, have you ever walked into a bookshop and thought you're overwhelmed by the choice you've got, or walked into a charity shop and thought the bookshelves are disorganized, you don't know where to start? So we thought it'd be nice to have an app that could solve that problem. So as you can see here, there's some of the technologies that we used. Me and Matt were the backend team, and we decided to go fully serverless. I'll let the rest of the group talk about their technologies that they used, but on the backend side, I'll talk about the training side of the model that we used. So the first technology that we looked at and was relatively easy to use was the Cloud Vision API that Google services supply. As you can see, if you pass in an image, it returns text boundaries with the inner text inside them, and that's it. You get all the information back, and there's no way of distinguishing an individual book on that bookshelf. So we had to find a way to split the books into individual books, and that was our biggest challenge. Because if we've got all the text, we've got all the text boundaries, but we don't know which text boundary belongs to which book. So the route we went down was object detection, not image recognition. Image recognition is supplied by Google. However, it would not be able to draw and single out an individual book. It would just recognize that it is a book. So obviously this was very much a very involved process. Before we started the training process, there's a lot of pre-processing of the images that we had to do. We used a Python program that would basically draw labels around books to determine the boundary of an object that we want to detect. And that, in this case, it's a book. And we would use that image and the boundary and the label to get a Pascal VOC format. However, this format's still not ready for Tensorflow, which is the framework that we're going to use for the training. And in order to do that, we had to do further conversions. And we used another Python script that was supplied by the Google Object Detection API, and that would convert it to a TF record. And when we had that, and this was also a very frustrating process, we were able to train the model on the ML engine, and this again was very frustrating. We managed to get a data set of about 100 books and pass that in, and as you can see, here's the results. And once we were able to train the model, we were able to deploy it on the ML engine so that we can make predictions. Once we were able to do that, I'll pass over to Matt to talk about the other side of the backend.
Cheers, Leon. Hey, I'm Matt. I'm just going to talk you through some of the backend stack and the sequence of events that occurs when a user uses the app. So to start off with, the user signs in using their Google account. We use the Google sign-in to authenticate with Firebase so that we can then manage Google users within our Firebase app. Once we've received the access token for that authentication, we're also able to send it to the Google Books API to receive a user's bookshelves, specifically their bookshelf containing their favorite books. We can pull down their favorite authors and then send that back up to the Firestore database. Yeah, at this stage, I'd just like to explain, the reason we chose to use Firebase is because we can upload straight to Firebase storage and then have the other Google platforms that we're using read directly from that bucket. And also, Firestore DB allows us to get information back to the phone in real time, so we know exactly when that result image is ready for download. So yeah, we upload that image. The file name is the user ID, so we know who to send it back to. Once that image is uploaded, it then triggers a Firebase Cloud function. The image is then sent by that Cloud function to Google Cloud Machine Learning Engine and also Google Cloud Vision for text detection. The Cloud Vision text recognition will find all the text in the image, draw a boundary box around it, return the text within that box along with coordinates associated with that boundary. Simultaneously, CloudML is analysing the image using the Tensorflow model that Leon was talking about that we trained. It will find the books within that image and again return the coordinates associated with each boundary. Once we've got both of those results back, we're able to go through the text blocks, group them into the correct book boundary using the coordinates, and then once we've got those blocks of text grouped by book, we're then able to send it to the Google Books API once again, but this time we're looking for book info. So we return title, author, genre, publisher, etc. On the odd occasion where the text recognition isn't exactly right, we can then send the text to Google's custom search API, which will provide us with a autocorrect suggestion. We'll then send that back to Google Books API, and then hopefully we'll be able to get the correct result that time around. Once we've got that back, we're then able to filter through the collected book information using the favourite authors that we collected at the start of the process. And then once we've got those filtered, we can send it to ImageMagick, which is a command line utility that's available on the Firebase servers for image processing. So we send the books with the coordinates. It will draw a rectangle around each of the recommended books. And then once the image is annotated, send it back up to the cloud storage bucket. Once it's there, we can retrieve a signed URL. We can stick that signed URL into the Firestore database. The update to the Firestore database will trigger a snapshot listener that is running on the phone app. So we know as soon as that goes in, we can pull down the new annotated result image and display it on the phone screen. Okay, I'm going to hand you over to Karen now, who's going to talk about the front-end app.
Okay, so for the front end, we used Expo and React Native. The reason why we used that was because it supports both iOS and Android. That allowed us to build an app for both platforms using just one code. React Native is also similar to React, which we've used during the course, so we were familiar with the syntax. It's also good for testing. It was really easy to test with it. It also provided real-time updates as and when we made changes to the code. We've also got a demo of the app. So on the login page, there's a link that redirects to the Google Books website if they don't have a Google account. There's also a button to log in, which redirects to the Google website. Once they've logged in, it'll ask for permission to access their Google Books account. Once they've signed in, they're redirected to the main page, and then there's a button to click on the camera. Once they click on the camera, it brings up the camera, and then they take a photo. Once they take the photo, this is sent off, and while you're waiting for a picture, there's a loading page which comes up. And then when the image is received, the image is returned back with the recommended books, which is all highlighted. There's also a home button, which allows the user to go back and take another picture of the bookshelf. So that is our Shelfy app, and I'll pass you over to Marta.
I decided to talk to you about some of the things that didn't quite make it to the app but were present at while we were researching, investing our time, and obviously trying to find the best technology for what we needed to do. So if we can move on to the next slide. So first one that we sort of looked at that seemed to be able to do the job was the IBM Power Eye Vision machine learning, and I've sort of taken a screenshot of the stuff that they were capable to do, and it seems like it's exactly perfect, exactly what we need. So if we can move on to the next slide, please. So just to say, Power Eye allows you to, very easy interface, allows you to put models, put labels over the books and train them, deploy the models, and then use API. So, like I said, I was kind of really excited about it. So then we had training. So then obviously our models, few versions of Shelfy. And then, so first sample, 200 labels, and the results were a little bit disappointing. So we were getting inconclusive results, which is probably the worst thing, because some of the photos were not recognized at all, no books at all, even like a shelf full, and sometimes we get quite good results, so it's inconclusive. So then we almost wanted to completely abandon the idea, but we consulted with with James, who sort of said maybe we need to look at how many samples we've done. So increase the samples to 500, and we got a slight improvement. It's still, however, not within the book boundaries, and our target was, for this to work, was to get exact book boundaries, and yet 500 levels didn't quite do it for us, so I've got to move to the other side. So the lesson from this was, I guess I've not given up on it. So I want, if given more time, I would have quite happily sort of done a bit more and see where that will take us, because IBM are kind of,